Welcome to my channel. Today we will discuss about another numerical analysis topic which is called Gauss Elimination Method. So first let us have some basic theory about the Gauss Elimination Method. And after this theory we will start our practice sessions. Okay. So what is Gauss Elimination Method? So, why this Gauss elimination method is used? The Gauss elimination method is used to solve a set of linear equations. Okay, a set of linear equations. So, what is a set of linear equations? Set of linear equations is a group of equations which are linear and there are various unknown factors. What are these? Like the equations x plus y plus 3z is equal to 5, 2x plus 5y minus 3z is equal to 7, 9x plus 2y plus 7z is equal to 10. So you see these three consists of a system of linear equations, and here you can see that there are three unknown variables x, y and z. So this is a system of linear equations, and for solving these kinds of linear equations we use different numerical analysis techniques, and one technique, this is called the Gauss elimination method that we will learn today. That is the Gauss elimination method that we will learn today. Okay. So, Gauss elimination method we will learn today. Okay. So, before going to the Gauss elimination method, we have to know some basic things. First, the thing is that Gauss elimination method is a row reduction technique. Okay, row reduction technique. We will learn how we will reduce the rows, or in the Gauss elimination method, after reducing the rows or after doing some operations on the rows, we will find a form of the matrix which is called the row echelon form. Row echelon form. What is this? We will learn later. Now another thing we will learn here, that is called augmented matrix. So what is augmented matrix? So the term is called the augmented matrix. What is an augmented matrix? Suppose there are three equations like this: x plus 2y plus 5z is equal to 8, 2x minus y minus 3z is equal to 7, y plus 9z is equal to 10. Okay. So you see these three are the equations that we need to solve. And first we have to find out the augmented matrix. What is the augmented matrix? Augmented matrix looks like this. First we have to find out the coefficient matrix. So there is a vertical line, as we can see in the matrix, and on the left hand side of the line of the vertical line, we will write the coefficient matrix. So what is the coefficient matrix? It is basically the matrix consisting of the coefficients of the equations. So for the first equation, so suppose this is first one is equation number 1, second one is equation number 2, third one is equation number 3. So from equation number 1, we see that the coefficient of x is 1. That is only x, so coefficient is 1. For y, the coefficient is 2. For z, the coefficient is 5. And on the right hand side, we will write the values of the equation, that is 8 here. Okay, so that first row corresponds to the coefficients of the first equation. Similarly, the second row corresponds to the coefficients of the second equation. So from equation number 2, what we find? We find that the coefficient of x is 2, the coefficient of y is -1, the coefficient of z is -3, and on the right hand side we write 7. In the third equation, we see that there is no x. So what we can say? That is the coefficient of x is 0. Okay. So here we put 0. The coefficient of y is 1. The coefficient of z is 9. And finally, on the right hand side, we write 10. So this form of the matrix is called the augmented matrix. Okay. So for any kind of elimination method that we will use to solve the system of linear equations, we have to first find the augmented matrix of the equations or the system of linear equations. Okay. So now we have to know other basic things which are called the row operations. So, sorry. Which are called the row operations. So what are the row operations? Row operations on the matrix. So these row operations will be applied on the augmented matrix. First row operation is called the swapping or interchanging of rows. Swapping or interchanging of rows. Okay. Second one is called, so let us take an example of the first one. That is, suppose there are 3 rows in a matrix, R1, R2 and R3. So R1, R2 and R3. Suppose these are the 3 rows in our matrix. So swapping or interchanging of rows means, suppose in this matrix, in a matrix, if we just interchange the position of row 2 with row 1, that is, in the new matrix, row 2 will be the first row and row 1 in the previous matrix will be the second row in the new matrix. Okay. Second one is multiplying second row operation. That is, multiplying a row by a non-zero number. Multiplying a row by a non-zero number. Suppose a non-zero number is k, which is non-zero. Okay. It may be greater than 0. It may be less than 0. But it cannot be 0. K cannot be 0. So k is a value which is a non-zero number. Okay. Now, with any row, that is, suppose we take R2, R2 can be multiplied with K. That is allowed. R2 into K, or what we can write, KR2. So that is also allowed, KR2. The third operation, third row operation is adding a multiple of one row with another row. Adding a multiple of one row to another row. What is that? Here is, you see, we have multiplied the row R2 with K. So that is one thing, a multiple of one row, that is KR2. Now what we can do? Suppose there is another row R3. R3 can be added to KR2. That is also allowed. In this case, you see that we have only, so these are the three operations, row operations that are allowed. So here you see in case of rule number 3, that is row operation 3, there is no provision of subtraction. So what we can do, just we can do R3 minus of K into R2. So that is allowed. Sorry, R3 plus minus of K into R2. If we just subtract, if we just want to do that, R3, that is not equal to, R3 is equal to, if we want to do that, R3 is equal to R3 minus K into R2. So what is that basically? R3 is equal to R3 plus minus K into R2. So that is addition, but we are adding a multiple of row R2 which is multiplied with minus K. So this is the same thing of addition. Similarly, if we want to divide a row with a number, with a non-zero number, here only multiplication as per the row operations, here only multiplication is possible, okay, but division is also possible. But how? That is R3, suppose we want to divide R3 with K. So R3 by K, we want to write this R3 is equal to R3 by K, but that is not allowed here. So only multiplication is allowed. So what we can do? R3 into 1 by K. So that means R3 by K. So here we divide using this, using multiplication. Here we can subtract in rule number 3. Here we can subtract with adding negative number. Okay. So these are the three row operations, elementary row operations that are needed for Gauss elimination method or any kinds of elimination methods. Okay. Now, just let me delete this page, delete these contents. Now, what we can do? We take an example so that we can understand how to do the Gauss elimination method using the row operations or using the elimination methods. So the example, Gauss elimination method example. So here I will give you two examples. For the first one, we will see a thing. For the second example, we will see another thing. Okay. So the question will come like this. Solve the following system of linear equations. Solve the following system of linear equations. Okay. So equations are like this. X plus y plus z is equal to 2. Then x plus 2y plus 3z is equal to 5. Then 2x plus 3y plus 4z is equal to 11. Now what we have to do? First we have to make the augmented matrix. Okay. First we have to make the augmented matrix. That is step 1. Augmented matrix. So how we can form this? We have already known to it. So what are the, from equation number 1, what are the coefficients of x? That is 1, y 1. For z, the coefficient is also 1. On the right hand side, we write 2. For the second equation, we write for x it is 1. For y, the coefficient is 2. For z, the coefficient is 3. And on the right hand side, we write 5. For the third equation, the coefficient of x is 2, the coefficient of y is 3, the coefficient of z is 4, and on the right hand side we write 11. Okay, so this is the augmented matrix. Now on this augmented matrix we will do the operations of what we have learned, that are the row operations. Okay, so we just see the augmented matrix. We have just rewritten the augmented matrix is like this, that we have obtained from our equation. Okay, so now what we have to do, what is our objective? The objective is, previously just I have mentioned, the objective is to find the row echelon form of the matrix. Row echelon form of the matrix. So what is the row echelon form? Row echelon form is basically a form of upper triangular matrix like this. That is, all the diagonal elements will be 1, and below the diagonal elements the values will be 0. Okay, and above the diagonal elements the values may be anything, and there may be anything. So the main thing is that the diagonal elements will be 0, and below the diagonal elements all the values will be 0, and above the diagonal elements the value may be anything. Okay. So that is the row echelon form of the matrix. In Gauss elimination method, we have to find the row echelon form of the matrix from this augmented matrix. So for this, we have to do the row operations. The first row operation, so here you see what we have just told you, the diagonal values will be 1. At this place, you see that 1 is already there. So we have nothing to do. But what we have to do? The elements below this diagonal element, that is the first value of the matrix, that is at the position, first position. And at the first column, the first value will be 1. The second value will be 0. The third value should also be 0. So what we have to do that? We have to do the basic operations. What we have just learned, we have to do the row operations. So here you see, so what we can do, just name this R1, R2, R3. What we can do? This one should be 0. So just do that. R2 is equal to R2 minus R1. Okay. R2 is equal to R2 minus R1, but this is not allowed. So what we can do? R2 is equal to R2 plus minus 1 into R1. See, there is 1. So if we subtract minus 1 from this, then only this will become 0. So only this kind of operation is allowed. So here it is 1. At the first place it is 1. So just we multiply minus 1 with row R1 and we add it with row 2. So what will happen? So 1, 1, 1. The first row will remain unchanged. It is 2 in the second row. R2 means that is 1 plus, and R2 plus minus 1 into R1. Minus 1 into R1. R1 means 1. So 1 plus minus 1 into 1. Second one, 2 plus minus 1 into 1. Third one, 3 plus minus 1 into 1. That is the thing. So what is that? So it will be 0. It will be 2 plus of minus 1. That means 1. 3 plus of minus 1. That will be 2. It will be 5 minus. So 5 plus minus 1 into 2. That means 5 minus 2. That means 3. So the second row will be 0, 1, 2, 3. Okay. So let me just write down properly so that you can understand. So 0, 1, 2, 3, 5. Sorry, 0, 1, 2, 3. Just we have operated this. And the third row will remain unchanged. 2, 3, 4, and it will be 11. Okay. So that is our step 1. Now, you see, now in the new matrix, the second value of the first column, is 0, but the last value of the first column, that also should be 0, but now it is 2, so we have to make it 0. So in the similar way, we have to make it 0. So what we have to do? We have to do like this. So when you are considering column 1, do finish column 1 first properly. That is, the diagonal element, that is the first element, should be 1 and the remaining element should be 0 at column 1. So never look up at the other columns, just finish the column one by one. So when you are at the first column, just finish the first column. So we have to make the third value, that is 2, we have to make it 0. So what operation we have to do? R3 is equal to R3 plus, it is 2. So if I do this operation, R3 plus minus 2 into R1. So if I just add 2 plus minus 2, that will be 0. So instead of writing in that simpler way, we are writing in a way that is allowed. That is the row operation. R3 is equal to R3 plus minus 2 into R2. So what is the new matrix? Just consider the previous one, that was 1, 1, 1, 2. Now the second row remains unchanged, 0, 1, 2, 3. So it comes from this. Now the third one, 2 plus minus 2 into R1. My R1 means 1. Okay. So it becomes 2 plus minus 2, that means 0. Then this position is 3. So 3 plus minus 2 into R1. R1 means 1. So 3 minus 2, that means 1. Next value, 4 plus minus 2 into, this is also 1, minus 2 into 1. So this becomes 4 minus 2, that means 2. And here on the right hand side, it was 11. So 11 plus minus 2 into 2. That means 11 minus, so that means it is 11. 11 minus 4. 11 minus 4 means 7. So 0, 1, 2, 7. So final matrix becomes like this. Just I'm deleting these portions so that a clear view is there. So the values after the operations, the values of the matrix are 0, 1, 2, and 7. Okay, so this is the matrix after this row operation. So now we see that this column is finished because only the first value of this column is 1 and the later two values, the below values are 0. So first column is complete. Now on this matrix, we have to do the other row operations so that in the second one, we can find in such a way so that this becomes 1. Already it is 1, so we have nothing to do here. But this value becomes 0. The lower value becomes 0. So upper value may be anything, but the lower value, that is at the third row, the third row value should be 0. Third row, second column, it should be 0. But the diagonal value, that is the position row 2, column 2, it is 1. Okay. So now we have to make this value 0. So what should be our row operation? Our row operation is like this. Now you see our new row 1 is 1, 1, 1, 2. Our new row 2 is 0, 1, 2, 3. Our new row 3 is 0, 1, 2, 7. Okay. Now, for making this one at column 2, the last value, for making the last value at column 2 0, what operation we have to do? We have to do the operation like R3 is equal to, now do not concentrate on column 1. Column 1 is finished. Now you just concentrate on column 2. So row 3 is equal to row 3. This should be 0, row 3 plus minus 1 into row 2. Now we are doing with row 2. So what will happen? What will be our new matrix? Just let me do it. So you see that I have written it in a fresh way. This was this matrix that is visible. That was our last matrix, which was the first row, row 1, R1, the second row, R2, the third row, R3. Now if we do this operation, R3 is equal to R3 plus minus 1 into R2, that just I have explained. What will happen? 1, 1, 1. The first row remains unchanged. 0, 1, 2, 3. The second row remains unchanged. The third row, R3 is equal to R3 plus minus 1 into R2. So 0 plus minus 1 into 0. So it becomes 0. Then 1 plus minus 1 into R2. That means 1. So it becomes 0. Then 2 plus minus 1 into R2, that means it is 2. So it also becomes 0. Then it is the third one. Just I am writing here 7 plus minus 1 into R2, that is 3. So 7 minus 3, that means 4. So if I write it properly, so it is 0, 0, 0, 4. The matrix looks like this. After doing this operation, the matrix looks like this. That is 1, 1, 1, 2, 0, 1, 2, 3, 0, 0, 0, 4. Now you see, if this kind of matrix comes where at any row the values are 0, then we cannot find any solution of this matrix, okay, or any solution of these equations, because that is inconsistent, which actually implies 0 is equal to 4. That is not possible anyhow. That means the solution, the matrix is inconsistent. So, or what we have to write, there is no solution, there is no solution for the given system of linear equations. Okay, so that is the output of this Gauss elimination method. So in the next lecture we will see when the equation is consistent or the matrix is consistent, and we will find the solution. Thank you.